Okay, hi everyone. So let's proceed with all the example for Tbat. So let's have a look at the first question over here. A 0.71 meter cube tank contains of 4.5 kilogram of an ideal gas. The gas has a molecular weight of 44 gram per mole and is at 21 degrees Celsius. So what is the gas pressure? So for this, there is no specific name for the gas, but yeah, it has been stated that it's an ideal gas. So definitely we are going to use the equation or formula to solve this particular question. So next, we are going to list out all the informations that has been given to us. So we have a tank that contains of 4.5 kilogram, which is the mass. And then they have the volume, so equal to 0.71 meter cube. The gas have a molecular weight of 44 gram per mole. So basically it's the same as 44 kilogram per kilomole. So this is the tank. The volume is actually the volume 4. The tank 0.71, okay. And then we have the temperature. Temperature is 21 degrees Celsius. So again, we just convert it into the Kelvin, 294.15 Kelvin. So from here, they require you to find the gas pressure. So the gas pressure can be determined using the ideal gas equation PV equal to mRT. So the pressure is what we are going to find. Volume, we have the value. Mass, we do have the value. And the temperature, we do have the value. So now we need to determine the specific gas constant, and we know that for the specific gas constant, it can be determined using the formula of R equal to RU divided with the molar mass, where the universal gas constant RU is equal to 8.314 kilojoule over kilomole Kelvin. So from here, we can get the value for the specific gas constant R equal to 8.314 divided with 44, and we're going to get 0.1889 kilojoule over kilogram Kelvin. And then we can use this to determine the pressure, since pressure can be determined using P equal to mRT divided with the volume. So the mass will be 4.5, and then the specific gas constant 0.1889. The temperature is 294.15, and then we have the volume, which is 0.71. Thus, you're going to get the pressure is equal to 352.17 to 1 kilopascal. All right. So next, we're going to look into the second question. So it states here, find the change in the specific internal energy, which is a small u, and it should be in terms of per kilogram unit. Find the change in the specific energy of 10 kilogram of oxygen gas. So again, look at the substance. It will be the oxygen, which we are going to use later in our analysis, is the formula or equation for the ideal gas. Alright, and then when the temperature changes from 38 to 50 degrees Celsius, so other things that has been given to you over here is the mass and then the initial temperature T1 and also the final temperature T2. Right. So for this, we know that to find the change in the internal energy is equal to CV T. So this will give you in the unit of kilojoule over kilogram. Right. So now we do have the informations for T1 and also T2, but we doesn't have the value for CV for the oxygen. Since there is no information on that given by the question, then we can look into the property tables. So for this, you're going to refer to table A2, and you can see there is the oxygen, and we want to know about the CV, which is 0.658 kilojoule over kilogram Kelvin. So over here, the specific heat at constant volume CV for the oxygen is equal to 0.658 kilojoule over kilogram Kelvin. So the changes in the internal energy will be 0.658. T2 will be 50 minus 38. Okay, so you can either use the degree Celsius or Kelvin, but if let's say you want to be consistent, then you need to convert this first into Kelvin. So for this, it will be 50 degrees Celsius is equal to 323.5 Kelvin, and for 38 degrees Celsius, it will be equivalent to 311.15 Kelvin. So here you're going to get the value for the internal energy in terms of kilojoule over kilogram, and you're going to get the value is equal to 7.896 kilojoule over kilogram. So next, let's have a look at the third question for the Tbat. An ideal gas is enclosed in a cylinder with a weighted piston as the top boundary. The gas is heated and expands from a volume of 0.04 meter cube to 0.1 meter cube and a constant pressure of 200 kilopascal. What is the work done by the system? So if you look here, they only states that it is an ideal gas. So there is no specific gas, but we know that it is a gas. And we are going to use all the formulas and equation related to the ideal gas to form our analysis for this particular question. Alright, so what else that we do have is the process is involving with heat and expansion from volume, which is volume 1 equal to 0.04 meter cube, and volume 2 is equal to 0.1 meter cube. And the constant pressure, so will be isobaric process, P1 equal to P2 equal to P equal to 200 kilopascal. For this, we know that the work is the boundary work P dV. Thus, what do we have over here is P V2 minus V1, and then we have the work 200 times V2 is 0.1 minus with 0.04, and you're going to get the value for the work in kilojoule is equal to 12 kilojoule.